This example is an hypothesis testing for a population mean. So example 1. Over the years, a market gardener found that the mean yield for his tomato plant was 1.93 per plant, with a standard deviation of 0.35 kg per plant. 1 year he planted 600 new variety of these and it yielded 1.87 kg per plant. At the 5% level of significance, test whether the mean yield from the new plant is different from his normal variety. So thinking back to when you did hypothesis testing for the population proportion, the steps are going to be the exact same. So part 1, you're going to have to write down what your hypothesis is. Okay, so the first of all, it is that the mean, which we denote as mu, and then is 1.83. Some people prefer to just write it as mean is equal to 1.83, like that, without words at all. And then the alternate hypothesis is the mean mu is not 1.83. So the alternate hypothesis, which you can write as HA or H1, it's going to be the opposite of that. So then if you wanted to write it without words, you do the mean is not equal to 1.83. This time, it doesn't mention anything to us about confidence intervals. So we're just literally testing at the 5% level of significance. So that is the 0.2. Now, what we mean by that is the critical region is z or less than 1.96 and greater than, less than minus 1.96 and greater than 1.96. Where that comes from is 2 standard deviations away is 1.96, and 2 standard deviations away, the opposite direction, is minus 1.96. So we're looking for the 5% level of significance is what's outside. So that's where that comes from. And then we have to calculate the test statistics. We're actually looking to calculate what z is equal to. So we're going to compare our values. If we find that z is going to be greater than any of these, we're going to reject this first one. If it's going to be inside this bell curve, which is inside the 95% limit, then we're going to accept the first one. Okay, so first of all, we have to calculate our test statistic using the formula, which we've used already. So you write the formula down. It's given to you in your log tables. You can see it here. It says hypothesis test and 1 sample z test. So this is the formula here, given to you. And then you're going to fill in your values. So we have our mean already. Our sample mean, which is 1.87. Our mean, which is 1.83. And then it's all over the standard deviation, which was 0.35, all over the square root of n, which was 600. And then we can put the full thing into the calculator and it'll give us our answer, which was 2.797. So that will be our test statistic. So let's move this up. So that is our test statistic. So now, so that's our value for z. So since z is equal to 2.797, which is greater than 1.96, then we're going to reject H0, the null hypothesis. And then, so we conclude that the new variety of potatoes, or whatever it's talking about, tomatoes, the new variety is different from the normal variety. So just to go through that conclusion again, where that comes from. So 2.797 is way up here. If it was within this, we would be within the 95%. But since it's outside, it's going to be in the 5% outside. So there's 2.5% on either side. So since it's outside, we have to reject the first one and accept the second one. If it was less than, it would be the opposite way around. Second example here we have is based on the p-value. So calculate the p-value of the sample for this test statistic z is equal to minus 2.08. So what we have to do to find the p-value, we need to find not only the p-value for over here, minus 2.08, we also need to find the p-value for the other side. Okay, so plus 2.08. So we're looking for the outside, any values outside of that. So what we need to do first of all, we cannot find, using the log tables, we cannot find the value of minus 2.08. So what we're going to have to do is find the value for 2.08, which will give us the probability for everything below all of that. Then if we take that away from 1, we'll be left with what's left up here. And then if we times that by 2, we'll get what's left on both sides. Since it's a normal distribution, both sides are going to be the same. So just taking it step by step, what we're going to find to get the p-value, it's going to be 1 minus the probability that z is less than or equal to 2.08. We're going to do that first of all. So it's going to be 1 minus the probability. If we look at 2.08 here, we have 2.0 go over to 8. So 2.08 is 0.9812. So 0.9812. If we take that away from 1, so it's going to be 0.0188. And then there's going to be, so that'll give us the area of one of these sides. Now, since we're looking for two of them, we're going to times it by 2 and get our p-value, which is equal to 0.0376. Now, just making reference to what we're going to do next, the next example is going to be on hypothesis testing, and we're going to use the p-value. So the smaller the p-value, the stronger the evidence against the H0, or the null hypothesis. Okay, so this one here would be like we're used to the 5% level of significance. This is like a 3.76% level of significance. So it's much, much stronger. It's much more specific than the original level of significance.